Moving your character throughout the scene is a very important part of every 2D game. To move our character throughout our 2D game, we have to add some physics components to our player, then take input from the user and map that input to the physics components we added earlier. This video is part of a much larger series where I cover everything you need to know for building your own 2D side view game. The project is available for free through my GitHub account, and you can access that by clicking the link in the description below. Please be sure to like this video and subscribe to the channel, and also check out my Patreon account if you want to donate that way. Also, be sure to follow us on our social media accounts to get updates on the latest videos. Alright, so in Unity we need to add our physics components to our character, so let's add a rigid body 2D component by clicking the add component button and searching for rigid body 2D. This component is going to control the different forces like gravity that we want to affect our character. I'll leave everything as its default value for now, except I'd like to expand the constraints drop down and freeze the rotation along the Z axis. Now if I click play, our character is going to be affected by gravity and fall through the bottom of the camera view. To prevent this, we need to add a collider to the character, and we need a collider beneath the character to act as a ground holding them up. To add a collider to our character, I'll select the add component button again and search for box collider 2D. Make sure to adjust the size and offset values so that the green gizmo box fits nicely around the outside of the character. Pay special attention to the bottom of the collider, aligning it with the bottom of the character's feet or whatever point is going to come into contact with the ground. Now we need to create a ground, and I'll need a sprite to fill up the box collider that we'll use for the ground. So I can create a symbol box sprite inside of Unity by right clicking in the project panel, navigating to create, highlighting sprites, and selecting square. Then let's create a sprite in the scene to hold the square by right clicking in the hierarchy panel, navigating to 2D and selecting sprite. Then let's drag in our square sprite into the sprite renderer component, and I will also reset the transform of the new sprite game object. Let's reposition the sprite to beneath the character and add a box collider 2D to the game object. Let's rename the game object to ground just to keep things organized. And let's write our script that will take input from the user and apply that input to move our character. Let's create a new script by right clicking in the project panel, navigating to create and selecting C# script. And I'll name this script move. So we can double click it to open it in Visual Studio. And let's get rid of these comments and change the update function to a fixed update function. It's a good idea to always use the fixed update function instead of the update function when we're dealing with physics components. And so let's create a few new variables for our script. Next, we'll need a couple floats. We'll need one for the player's walk speed. That's pretty self-explanatory. We'll need one for the air speed or the horizontal speed while the player is in the air. And we will also need a float for the jump thrust. Before we start in the fixed update function, let's create a new local function. We can call this function move, and it will just take a float as a parameter. We want this function to modify the rigid body velocity based on the input given via the parameter. So Unity has a few different ways to collect input. I recommend getting movement input using the getAccess function. Since we're really only moving horizontally, we just need the horizontal axis. So we can use our function to map the input to our character. Let's run our script and check that everything is working. Make sure to apply the script to the character and then drag in the rigid body component into the variable of the script. When I run the game, the character moves right to left with the arrow keys, or they could move with the WASD alternative. Let's reopen our script and work on the jumping aspect of our movement. I'll create a new local void function called jump, this time changing the rigid body velocity in the y-axis. Next, I'll actually recreate the update function because we're going to need that to collect input from the user. I'll write an if statement that checks if the jump button is called and calls the jump function when it is. Now, when I run the game and jump, our player in fact moves up and moves back down, being affected by gravity until they collide with the ground again. One of the problems we have though right now is that we only want our player to be able to jump when they're in contact with the ground. Otherwise, they'll have nothing to push off from. So first, let's create a new tag for the ground by selecting the ground game object in the hierarchy, navigating to the tag dropdown and selecting add tag. Click the plus icon and enter ground. Now in our C# script, I'll create a new bool that will track if our player is currently grounded. I'll write a new function called onCollisionEnter2D that will be called every time a new collision is detected. We want to inspect the game object we collided with, comparing the tag to the keyword ground, which is the same as the tag we just made. If the object we collided with is the ground, then we want to set the isGrounded bool to true. Let's make sure to set the isGrounded variable to false automatically every time we jump. Now in our update function, we only want to call the jump function if the correct input is given and the player is currently grounded. First, I'll just demonstrate what it'd look like if the player could jump whenever they like. And you can see that the player can jump without having any contact with the ground. Now with the isGrounded clause added, you can see that the player, actually I think we might have to go back and apply the tag to the ground. That's a mistake I make all the time, so you'll have to make sure to add the tag after you create the tag to whichever game object you are targeting. So now after I apply the ground tag to the ground game object and attempt to jump, you can see that the player can only jump if they're currently in contact with the ground. Alright, so finally let's modify the horizontal movement speed depending on if the player is airborne. So in Visual Studio, let's add a second float parameter to the move function for a speed multiplier. Let's replace the horizontal movement speed and the new rigid body velocity with the parameter supplied. Then let's check if the player is grounded, moving them along with the walk speed if they are grounded, and the air speed if they are currently not grounded. And if I make these variables a bit more distinguished, you can see a significant speed difference for the player when they are airborne versus when they are grounded. What's up everyone, thanks for watching. Please be sure to give this video a thumbs up and subscribe to the channel. Also make sure to follow us on social media to get the latest news updates.